So thanks everyone for joining. My name is Nick Vermandi. I'm a technical marketing with Cisco ACI business unit, looking after everything around open source, Kubernetes, and programmability in general. So the topic for today is going to be ACI, GitOps, and Terraform, and more especially how developers and platform admins can use their favorite cloud native tools to manage and automate infrastructure components such as ACI by using Terraform in GitOps Pipeline. So I'm going to be focusing on the demo, so I'm trying to go very fast on setting the stage here. But first, what is really GitOps? So GitOps is really a methodology or a practice that really aims at leveraging Git as the single source of truth, but also like in the normal CI/CD pipeline. But the difference becomes when you want to deploy your application into a Kubernetes environment. Traditionally, you would use something like kubectl or imperative commands to deploy into production, whether it's in an automated way with Jenkins or just manually. The difference here is that the Kubernetes manifest, so all the infrastructure definition will also be sitting on a Git repository as code, right? So obviously, it means that the Kubernetes admins or the platform admins, they don't deploy into production using kubectl anymore. So there are a couple of benefits of doing this. So first of all, you're codifying your infrastructure. So you have all the benefits of version controlling. So you can revert, you can better share as a team. But also there is concerns that are solved for security, because now you don't need any Kubernetes credential from your pipeline to be able to interact with your cluster, which is also a big improvement. So traditionally, what a GitOps pipeline really look like is first you're a developer, you push traditional, you merge your code into your Git repository, then you trigger the build via webhook or by using GitHub Actions, and this is classic CI, where you also build your container in the end as a result, as an artifact of your build stage. Now the difference will start with how you represent the underlying infrastructure, how you need to generate the corresponding Kubernetes manifests that are required by the environment. So typically you can use something like Customize that allow you to create manifest templates. And for example, let's say if the container gets updated by the build, then you can also trigger an update of your Kubernetes manifest where you're going to replace all the iteration or the occurrences of the image name into the Kubernetes manifest, let's say in the deployment, for example, to keep your image up to date when you're deploying into production. So this is where it starts, by getting all your Kubernetes manifests sitting on the Git repository. And now the next stage consists in deploying those manifests into your Kubernetes cluster. And for that, you would need some sort of GitOps tool, which in our case, for the demo, I'm using Argo CD, which is a well-known tool for that, but you can use Flux for other tools. And the idea is really to have a continuous watch of your Kubernetes manifest so that you can reconcile any drift between what is sitting in your infrastructure repository, so all the Kubernetes manifests, and inside your cluster. So for example, if someone create a new version of the release for your manifest, then automatically Argo will detect that you're out of sync, and you can either trigger the sync manually or automatically push the changes into the cluster. And the other direction also works. So if someone modifies something in the cluster manually, it will detect the drift and also signal that there is a drift in the environment. And as you consider Git as the single source of truth, then you may want to reconcile as well, like removing the manual change from the cluster. And actually, there are really two nice hooks that we are looking into this demo. So the first one is about the repository, the Kubernetes manifest, and how can you represent as code external infrastructure. When I say external, I mean anything that is not part of Kubernetes, but that is still required by the application deployment. So in our case, this would be ACI, and how we can secure the namespace for the application you're going to deploy by using our zero trust model. How to automate this, dynamically, just by using your GitOps pipeline. And of course, there is the second part, which is how do you maintain this always updated in your cluster. And for that, we're going to be using the Terraform operator, which is essentially encapsulating Terraform plans into a CRD and a controller that will reconcile all the drifts. So what I mean by that, if we double click on the Terraform operator, as a user, you interact with a CRD, which is a workspace. So CRD is custom resource definition. It's your own. You can define your own, Kubernetes object that is sitting in etcd. And there is a one-to-one mapping between the workspace as a CRD and a workspace in Terraform Cloud. So we have a one-to-one mapping between the workspace CRD and the Terraform plan, including inputs, all of that. So all the necessary parameters can be encapsulated into that CRD, and then you've got your Terraform custom controller that will permanently watch any modification on that particular object. So if you create a new workspace, it will trigger a new plan. It will run a new plan on Terraform Cloud, and it can be anything. It can be ACI, it can be other components, but that's the overall idea here. And we are going to be using our ACI provider, which can do anything in ACI. We can build tenant, VRF, bridge domains, subnets, EPGs, anything you can think of. And in our particular case, I'm going to be showing how you can map an EPG to a namespace in Kubernetes. So we have this one-to-one mapping we can also achieve in ACI, treating containers and Kubernetes objects as first-class citizen to enforce our security model. And because ACI is a zero trust model, by default, your namespace is isolated, right? So it's also increasing security over time. And because ACI has a consistent model across many different form factors, it also means that you can address your automation for Kubernetes, but also if it's depending on, let's say, a physical database or a VM or anything, you can also control your contracts and your connectivity to anything outside Kubernetes, except that now it's fully automated by the Kubernetes operator and the GitOps pipeline. So in our case, for the demo, we're going to be focusing on the second part, which is really showing how we can leverage the workspace CRD and the namespace EPG mapping, as well as the annotation. So let's get started with this demo. I'm going to switch to my demo environment. So first of all, this is the Argo CD environment, where you can see that I've got the two repos, one for my application, one for my infrastructure. Then in my application repo, you can see all the manifest that has been generated, and also that I've got my namespace annotation to map that particular namespace to the ACI EPG. So in the same way, you have the service definition that is leveraging type load balancer, which means that we will automatically create a in-hardware load balancer in ACI to expose that service to the outside. And if we look at the infra space, we can see that we have the Terraform inputs that are represented there as a config map. And we also have the workspace itself, which is encapsulating the Terraform plan I want to use. And this Terraform plan essentially is composed of resources that are required for me to create a new EPG and basically map it to my Kubernetes environment to make the container first-class citizen. So in my ACI environment, you can see currently I don't have any hello GitOps namespace. I don't have any container. And if you go into, in this demo, I've got actually two clusters, one cluster for my Terraform operator and one cluster for my application, right? So in the Terraform cluster, you can see I've got just my, my controller, but I don't have any, I don't have any workspace created yet, right? Same thing, I don't have any application deployed. I don't have my hello GitOps deployed there. So what we're gonna do is just reconcile the state. It's out of sync, right? So let's first go and deploy the application. I'm gonna sync this. And at the same time, I'm gonna sync the workspace. I think I still need to do this. Okay, so now I should have my application that is there, right? So you can see hello GitOps. So my application has been completely deployed. And if I look at my Terraform agent, right, which is running the Terraform plan on behalf of my environment in Terraform Cloud, you can see I'm running Terraform in it. So if we take a look at Terraform Cloud, we should be able to see some things going on. So we can see here, I've got my Terraform operator that is kicking in and live initializing all the plugins. So in Terraform Client is going to do first a Terraform plan. And if there are no errors, I'm going to do a Terraform apply. And once it's done, we should see also the results in ACI. So what we are expecting here is a new EPG created in ACI, as well as a, the container should also be visible in that particular EPG in ACI. So still creating. Okay, so now as an output, I can see that I've got this DN, which refers my ACI environment. And now I should see that I've got my hello GitOps EPG. And within that hello GitOps, I should be able to see the container that is part of my application. And so I think this is it for today. So I've shown that we can entirely manage security with EPGs in ACI, putting first-class citizen, container first-class citizen, and automating everything from the application layer without leaving your cloud-native tools. So a couple of other resources for you there. So if you want to take a closer look at the ACI provider, we also have ACI DevNet and Terraforms Labs, and also very interesting blogs on the HashiCorp website, promoting and talking about other use cases for the Terraform operators. Thanks very much for joining, and I hope you enjoy the rest of the conference.